In section 4.5, we deal with significant digits, and we also deal with setting up trig functions. In section 4.6, you actually do what's called solving a right triangle, and to solve a right triangle means that you find all the side lengths and angle measures. And also in 4.6, we evaluate trig functions. All right. So the first thing we want to take a look at is what are called significant figures or significant digits. So a significant digit are, and it's just these three rules, and they have something to do with zeros. Any number like 1 through 9, that's considered to be significant. The zeros, however, it says non-zeros are significant. So that means the numbers 1 through 9 are significant. Zeros between significant figures are significant. And then the third rule says trailing zeros after the decimal point are significant. So there's like a few questions that deal with significant digits. So let's take a look at, this is problem number 2, and this is again coming out of 4.6. And it wants us to give the number of significant digits for the following number. Well, I don't have any zeros, and if all non-zero numbers are significant, here I would have 1, 2, 3, 4, 5 significant digits. Okay, what is wrong with it? All right, so my solution here is 5. There's 5 significant digits. All right, for the next problem, it says give the number of significant digits in the following number. So notice we have 4.7000. Any zeros, and they call them trailing zeros after the decimal point, but any zero after the decimal point is significant, right? Because these zeros are after the decimal. So any zero after the decimal is significant. So if I were to count up the number of digits here, I would have 1, 2, 3, 4, 5 significant digits. Okay, so we would include those 3 zeros after the decimal. All right, and then the next one, number 4, it says give number of significant digits in the following number. We have 1,750. Notice that I don't have any decimal. I mean, the decimal is understood, like 1,750.0, right? I have a zero that's not in between significant digits. So the only number of significant digits here are 3, right? This 0 is not significant because that 0 is not between significant digits, and it comes before the decimal point. Right, so for problem number 4, there should only be 3 significant digits. I think there are like 5 or 6 problems that we're dealing with that. And just keep these 3 rules in mind. All right, next we get into some right triangle trigonometry. So I'm just going to slide this over. So here are some okay, this slide wasn't actually on my Yeah, I'm gonna get it together here in 1 second. Okay, so here are some right triangle facts before we start talking about any formulas. All right, so the first thing about a right triangle is a right triangle has a 90-degree angle within it. All right, that 90-degree angle is denoted by that square. If you don't see the square, it's not a right triangle. But in our class, we're dealing with right triangles. The second fact is, for a right triangle, you have two legs and you have a hypotenuse. The hypotenuse of any right triangle is always opposite the right angle. Another fact about the hypotenuse, it's the largest side, or I should say it's the longest side of any right triangle. So two legs and a hypotenuse, and it must have a 90-degree angle. The hypotenuse is always the longest side. The next couple of facts are, I'm going to put a star by this, if given two sides, you can find the third side by using the Pythagorean theorem. So now as we go through these problems, we try to set up the least amount of trig functions possible. So normally when we solve a right triangle, you may set up 1 or 2 trig functions, and then you can use some of these facts. Like this fact says if you're given two sides, you can find the third side by using Pythagorean theorem. The Pythagorean theorem is c squared is equal to a squared plus b squared. This is like the main formula. Okay, so this breaks down into 3 other formulas. C is equal to the square root of a squared plus b squared. Because in our problems, we never find c squared, a squared, b squared. In our sides of our triangles, they're simply going to be a, b, and c. So what I did here is I took the square root of both sides, and the square root and the square cancel out on that left-hand side. So c squared becomes c, and then the right-hand side becomes square rooted. So if you had to find c, and if you know a and b, you could use this formula. You can use this formula to find side length a. Side length a is equal to the square root of c squared minus b squared. And one last formula, b is equal to the square root of c squared minus a squared. Now here's an alternative set of formulas. I'm going to use like hypotenuse and leg instead of a, b, and c. So the hypotenuse square, that's equal to a leg square plus another leg square. So like the same form, but instead of writing a, b, and c, I'm writing leg, hypotenuse. These formulas are a little bit easier to navigate. So if you wanted to find the hypotenuse, you can simply take the square root of both of the legs squared. So that's basically the same thing as if c is equal to a squared plus b squared formula. And then if you wanted to find a leg, that would be equal to the hypotenuse square minus the other leg squared. And those would be the formulas. So if you're given two sides, you can find the third side, and we have the formula for A, B, and C using the Pythagorean theorem. Fact about a right triangle. Because all these things will come into play once we actually start to solve them. The sum of the interior angles of any triangle, not just a right triangle, but any triangle, and this includes a right triangle, is 180 degrees. So here is what that means. If we take a look at the triangle, if you were to add up all of the angles within this triangle, they would sum to give you 180 degrees. So that's a fact for any triangle, not necessarily a right triangle, any triangle. So based on the angles adding up to give you 180, okay, that just brings up one more last fact. If given two angle measures, we can find the third angle by using the sum formula. And that sum formula is based off the fact that if you add up or sum up all of the interior angles in any triangle, they have to equal to 180. So if you're given two angles of a triangle, you can add those two angles up, subtract from 180, and that'll give you that third angle. All right, so here's just some facts before we start dealing with all these formulas and setting up trig functions. All right, so just about 3 or 4 facts about a right triangle. All right, based on that right triangle, we have 6 trig functions, 6 trigonometric functions. So the way that this is break down, it says right triangle, base definitions of trig functions. The sine of angle A, that is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. If you look to the formulas next to those functions, for instance, the sine and the cosecant, they are what are called reciprocal functions. So reciprocal functions just means you flip your fraction over. So notice that the sine of A is the opposite over the hypotenuse. The cosecant is the hypotenuse over the opposite. Right? So it's a reciprocal function. The reciprocal of cosine is secant. The cosine is the adjacent over the hypotenuse, and the secant is the hypotenuse over the adjacent. Right? It's just reciprocated. And then lastly, the reciprocal of tangent is cotangent. Tangent is the opposite over the adjacent, and cotangent is the adjacent over the opposite. Right? So looking at these functions and the reciprocal functions, we mainly concentrate on sine, cosine, and tangent. And then once we find sine, cosine, and tangent, we can simply reciprocate to find the other 3 functions. All right, now there's an easy way to remember the trig functions. Okay? But like I said, that we're going to use what's called a mnemonic to help remember these first three formulas. And then for the last three, we can simply reciprocate. All right. So here is the slogan, basically. It is Chief Sakatoa. I don't know how many people heard this before. This is like how I learned this. So, all right. So this is what Chief Sakatoa means. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, right? So the cosine is the adjacent over the hypotenuse, and then the tangent is the opposite over the adjacent. There's another slogan. One says Oscar had a heap of apples. Anybody ever heard of that one? All right. So it alludes to the same thing. Oscar had, that's the sine. A heap, that's the adjacent over the hypotenuse, which is the cosine. And then of apples is the tangent. And then this is one I learned last semester. A student brought this up. There's a million of them. This one says one. I never heard this one before. One old hippie caught another old hippie tripping on acid. Right? One old hippie, so, oh no, it's some old hippie. I'm sorry. Because that S is for the sine, is the opposite over the hypotenuse. So that old hippie, the opposite over hypotenuse, caught another old hippie. So caught is the cosine, and then another is A, adjacent over the hypotenuse hippie. And then tripping on acid, tripping is for tangent. On is for opposite. Acid is for adjacent. But I'm going to use Chief Sakatoa because it's like short and sweet, and it has the sine, cosine, and tangent like prefix. All right. So any questions about the 6 trig functions? I know they may look kind of mysterious right now, but just remember that Chief Sakatoa is summing all of this up. All right, now we're going to use Chief Sakatoa. We're going to use the Pythagorean theorem. We're going to use that sum formula all in this one problem. So this is actually problem 14 and 4.5. You have some of these problems at 4.5 and then some of these problems at 4.6. Some problems only want you to find like one thing like A or C or B. In this problem, however, they want us to solve the right triangle. That means to find all of the side lengths and all of the angle measures. So let's take this kind of slow, all right? So here are the steps. Steps to set up a trig function. The first thing is you have to choose a reference angle. All right. So what is a reference angle? A reference angle simply means an acute angle. And an acute angle is any angle less than 90 degrees. which means that when we're choosing a reference angle, we can never use the right angle as a reference angle, because the definition of reference means acute, and a 90-degree angle is not an acute angle. So that's the first thing. The second thing we're going to do is we're going to label the sides according to the reference angle. So what do I mean by labeling the sides? Well, we're going to have to label one side the hypotenuse. We got to label one side the adjacent. We got to label the other side the opposite, and then we can use the chief SOHCAHTOA to navigate through, right, once we've labeled our sides. The third thing we want to do is set up a trig function. Set up a trig function using the chief. I'm going to just put it that way. So it's really just 3 steps. Choose a reference angle, label your sides, set up the trig function. All right, so let's look at number 14. Right, it says refer to the right triangle ABC with C equaling to 90 degrees as shown in the figure, which is not drawn on the scale. Solve all the remaining parts. The first thing I'm going to do is I'm going to plug in my given information into the triangle. So it says that A is 37 degrees. So I'm just going to jot a 37 for angle A. C is equal to 22 feet. Sometimes they'll give you the measurements within the triangle. Other times they'll just give you the triangle and they'll just list out the measurements separately. So here I'm taking those dimensions that were given, I'm just plugging into the triangle. All right. So now let's look at the steps. The first step says to choose a reference angle. I only have 2 reference angles, or 2 acute angles. That would be the 37 degrees and this unknown angle B. Since I know the value for angle A, this is my reference angle, 37-degree angle for A. So when I label my sides, I'm going to label my sides according to my reference angle. The first side I always like to label is the hypotenuse. So remember that in any right triangle, the hypotenuse is across from the right angle. So side length C is the hypotenuse. So now we have to identify the opposite and the adjacent. So next, if this is angle A, the side that's opposite angle A is the opposite side. So since side A is opposite angle A, side length A is opposite to angle A. And then by default, the very last side is my adjacent. So I'm going to kind of explain that adjacent concept. Adjacent means that 2 things share a common side. Like this room, C105, and the next room, they share this common wall. So this room is adjacent to the other room because they share this wall. If you look at angle A, and if you look at side length B, they both share side B. So side B and angle A, B is the adjacent to angle A. So any questions on labeling. Choose your reference angle. Label your sides according to the reference angle, because what angle you choose is going to switch up your opposite and adjacent side. All right. So now we're going to set up a trig function. The first thing that we're asked to do is find side A. So now if you're trying to find a side length, the first thing I would do is I would say, well, how many sides am I given? Well, they only give me one side length, so I cannot use the Pythagorean theorem, right? Because in order to use the Pythagorean theorem, you have to know two side lengths. So that means we have to set up a trig function. So what trig function we set up to solve for A? Well, let's figure out what we're dealing with. So if I look at side length A, side length A is actually the what? Opposite. So I must, since I'm trying to find A, I have to use a trig function that has the opposite in it. If I look at my sides, right, I don't know A, I don't know B, but I'm given the hypotenuse. And I'm also given my reference angle A. So what kind of function could you set up with an opposite and a hypotenuse? Well, if we look at the chief SOHCAHTOA, the sine is the opposite over the hypotenuse. So I'm going to use a sine function. So here's how I'm going to write that out. The sine of angle A, which is 37 degrees, that's equal to the opposite to angle A. So I don't know what that opposite side is, so I'm just going to leave it as A. That's what we're actually solving for. Divided by the hypotenuse, which is 22. And now we want to solve for A. So now here's the thing. Whenever you work with a fraction, you should always get rid of the fraction first. The way that you get rid of the fraction is you multiply both sides by the common denominator. So what I'm going to do here is I'm going to multiply both sides by 22. So I'm going to multiply the left-hand side by 22. I'm going to multiply the right-hand side by 22. So on my left-hand side is just 22 times the sine of 37. But on the right-hand side, the 22's cancel, and I'm left with A. So 22 times the sine of 37 degrees should equal to side A. So now comes the fun part, putting it in the calculator. And it all depends upon what calculator you have. I have the TI-83. I know everybody may not have a TI-83. I'm also going to use the calculator in Windows. All right. So first I'm going to use the graphing calculator. Let me just clear this out. I'm going to go into mode. And on this very third line, you see something that says rating in degree. For this course, we want to make sure that we are in degree mode. If you are using the Windows calculator, if you've never brought it up before, it's probably going to look like this when you bring it up. Notice I don't see any trig functions whatsoever. But if I go up to my hamburger menu, and if I click and access scientific, now we see sine, cosine, and tangent. You also want to make sure that you are in degree mode. So notice when I click this thing, it says degree, and this is the default. But then you have radian, and then you have gradient. We want to make sure we're in degree mode. Now, it's kind of goofy how you use this calculator in Windows. But on the TI-83, I can just put it in as 22 times the sine of 37 degrees. And it gives us 13.23, but we're asked to round to the nearest foot. So that would be 13. Right, so 13 equals the A. So now I'm going to use the Windows calculator. So this is going to be a little bit different. First thing I have to do using the Bill Gates system is I have to evaluate this trig function first. So you want to make sure you're in degree mode. In order to evaluate the sine of 37, the first thing I have to do is put in the argument. I have to put in my angle measure. So I want to hit 37. Then I hit sine. And then I'm going to multiply by 22 to get that same 13.2399. So know your calculator. Some calculators are like this one, you can just enter in as you see it. But if you're using the calculator on Windows, you have to put in your argument or your angle measure first. All right, any questions on finding side length A? Now we're going to find B. So A was 13, so I'm going to just jot that up into my triangle. That is 13. And now I want to find side B. Now, you could set up another trig function. But as I stated earlier, you want to set up at the least amount of trig functions as possible. To find side B, since I know two sides, I could use that Pythagorean theorem. And then we had a formula to find B from earlier. B is equal to the square root of C squared minus A squared. So for C, I'm going to substitute in 22. And A, we're going to substitute in 13. So B is equal to the square root of 22 squared minus 13 squared. So this is the square root, 22 squared minus 13 squared. And if we round to the nearest foot, we should get 18. Now, if you're using this Windows calculator, there's not a real easy way to put that in. I would, if I were using the Windows calculator, I would do this in parts. I would actually write it all out. So just to do a quick example of that, B is equal to the square root of 22 squared minus 13 squared. So like I said, a lot of this stuff depends on your calculator. So I would square 22. Okay, wow. So 22 squared, that's 484. 13 squared is 169. Then I would subtract those two. 484 minus 169. That's 315, the square root of 315. And then the square root of 315 is So you have to put in your number first, and then you have to square root it, and you get that 17.74, which is 18. All right, so side length B is 18. We're asked to find side length C, and I already gave that to us, right? That's 22. So find C, that's given, C equal to 22. Next, we want to find A. A is given. A was 37 degrees. And lastly, we have to find angle B. So in order to find angle B, since I know two angles, I'm going to use the sum formula. So B is equal to 180 degrees minus the sum of my other two angles, which are 37 degrees and 90 degrees. So it's 180 minus 90 degrees plus 37 degrees. 90 plus 37 is 127. 180 minus 127 is 53 degrees. All right, so angle B is 53 degrees. All right, next we have what are called cofunction identities. And these are some formulas, and they've already been proven, and we're simply just going to use them as they are. So here's what a cofunction identity is. It says that the sine of A, that's equal to the cosine of 90 degrees minus A. The cosine of A is equal to the sine of 90 degrees minus A. So notice that these formulas are dealing with, they actually have the same value. So just to show a quick example of what one of these functions look like. So I'm going to use this first one. So this example would be write a cofunction, let's say the sine of 30 degrees, right? And I want to write it as a cofunction. I'm going to look at my formulas, and I'm going to find the sine formula. So it says that the sine of A, so in this formula, wherever I see an A, I'm going to just substitute it with 30. It says that the sine of A is equal to the cosine of 90 degrees minus A. So we're going to substitute A for 30. So that's the cosine of 90 degrees minus 30 degrees. So we have something that looks like this. The sine of 30 degrees is equal to the cosine of 60 degrees. Which means that these things are actually have the same value. So what I mean by that is, if we were to evaluate the sine of 30, let's clear this out. The sine of 30 and the cosine of 60 degrees, they have the exact same value, just written a different way. So this is the purpose of the cofunction identities. So notice that the sine of 30 and the cosine of 60 are actually both equal to the same value, which makes these identities true. So let's look at a couple of problems. 5 says use the cofunction theorem to fill in the blanks. The tangent of 22 degrees is equal to the cotangent of blank. If I go back to my formulas, this third formula at the top says the tangent of A that's equal to the cotangent of 90 degrees minus A. So in this formula, wherever I see an A, I'm going to substitute it with 22. Just write this over so it looks a bit better. The tangent of A, that's equal to the cotangent of 90 degrees minus A. This is the formula. And then this is our problem. The tangent of 22 degrees. So in my formula, I'm going to substitute A with 22 degrees. So that's equal to the cotangent of 90 degrees minus 22 degrees. 90 minus 22 is 68. So my answer is 68 degrees. All right, so the answer there should be 68. Problem number 7, it uses the same cofunction theorem, but it doesn't actually give you a value. It uses a variable y. These formulas can actually be used in reverse. So what I mean by that is the sine of 90 degrees minus y. If I were to find that in my formulas, the sine of 90 degrees minus y, that would be the first formula on that last row. And I would substitute A for y. So that means that the sine of 90 degrees minus y, that should simply equal to the cosine of